Hello and welcome to lesson 4-2, which is adding polynomials. So today we have two learning targets. One is going to be to use algebra tiles to add polynomials, and then we are going to add polynomials algebraically. So we'll look at both of those. Okay, so we're back to our application problem, which is the solar panels again. And it says that notice that in the solar panels at the right, there are 4 squared or 16 cells. Each column has 4 cells. If a square solar panel with an unknown number of cells along the edge can be represented by x squared, how many cells would be in one column? Well, there would just be one, because x times x is what's going to give us the x squared. Okay? So a square solar panel with x rows and x columns can be represented by this square. Okay, whereas if we have a solar panel with, it's just a column of x cells, so that'd be like x by 1. Okay, so we have, x by x, we have 1 by x, and then finally we have a little 1 by 1 that will make the one singular solar cell. Okay. So we can use these algebra tiles then to help us combine expressions. But first we're going to learn how to actually make an expression using them. So suppose there were 3 solar panels that each had x columns and x rows. So that's going to give us our 3x squareds. Then there's 2 columns with x cells. And then there are 3 singular solar cells. That's plus 3. So now let's try to make our own. Okay, so we have x squared, 2x squareds. So that means I want to make 2 squares. Okay, but we have minus 3x. So to show that, it's almost easier if you just use a different color. So to make minus 3x, we're actually going to use negative. We're going to use the little columns for minus 3x. Okay, so there's minus x, and minus x. And then back to positive again for 2 singular solar cells. So there are 2. So if we can do that with 2 polynomials, then we could combine them together pretty easily, and it's a good visual method. Okay, so now let's go to the next page, and we'll look at an example where we're actually going to model each polynomial, identify and remove some 0 pairs, and write a new polynomial. So here we want to add together the polynomial of 3x squared minus 3x plus 2x squared plus 5x plus 3. So first we model the polynomials. So we have each of those here. And what you'll notice is you'll have some 0 pairs that you can move out. So if you see positive x squared with negative x squared, they're going to make a 0. Okay, and so we see that we don't see that with the x squares, but we do see that with the x's. So we actually have 3 negative x's right here, and then we have 5 positive x's, so like 3 of them will cancel. Okay, and we'll only be left with 2 of them. We can see those 2 right here. Same thing's going to happen with the singular solar panels. We have negative 5 over here, and with those negative 5, they're going to get combined with positive 3. So you have negative 5 and positive 3. That really just means like 3 of these negatives will cancel with 3 of these positives. And you're just going to be left with the 2 negatives right there. So that's what we're going to do. So we'll try one of these where we set up the tiles and then we actually solve. So let's look at part C here. So I'm going to start by modeling the first polynomial. I have 2x squareds. Okay, so let's make 2 squares for x squared. These are positive. Okay, and then I have 3 x's, which are also positive, so I'll continue using red. 2, 3, those are my x's. Okay, and then I have 9 singular solar panels, so 9 little squares. 1, 2, 3, 4, 5, 6, 7, 8, and 9. And what I need to do is I need to add those to the second polynomial, but if I notice that one is all negative, so I actually have to make them in a different color. So I'm going to make a negative x squared, so I'm going to have one of those that are negative, and then 4 negative x's, so I actually have 4 of these. Okay, and those are all negative x's. And then I actually have negative 6 singular solar panels, so I'll make 6 of those. Okay, and now we can eliminate any positive x squareds with negative x squareds, and that's going to be our what we consider our zero pairs. So those are gone. We're left with 1x squared. And then we had 3 positive x's, and we can get rid of 3 negative x's. That'll make 0. We'll be left with 1 negative x. And then we have 6 negative 1s, and we can get rid of 6 negative 1s, and we're going to be left with 3 negative 1s. Okay, so for our final answer then, we could write x squared minus 1x, and then these are actually positive ones. We're going to have 3 positive ones. Okay, and that's how we can do it using algebra tiles, but that takes a long time, so we're not going to always do it that way. So we're going to actually do it using a method called combining like terms. So like terms are terms in an expression that have the same variable and exponent for that variable. And all constants are like terms. We're going to state whether the terms are like or unlike for each one of these, and we'll explain why. So for part A, we have 2x and 2x cubed. We would say that these are not like terms because they have the same variable but a different power. Okay, for B, we would also say not like because one has a variable and one does not. C, however, you can see they both have y to the first power. Coefficient doesn't really matter. Same variable, same exponent for the variable. So these are going to be considered like. Okay. D looks like it would want to be like terms. However, if you notice, the x is squared in the first expression, but the y is squared in the second expression. So that is going to be not like. For E, we have both constants. Well, constants are always like terms. So we can always add those together. We'll call that like. And then for F. For F, I have an x squared and a y squared. They both have squares, but they are different variables. So we're going to go with not like. So like terms are what we're going to want to combine. And so that's what we're going to do instead of using algebra tiles. We're going to add polynomials. Okay, so we want to add polynomials by combining like terms. Okay, and when we combine like terms, we only add coefficients. We don't do anything with the powers. And so we'll practice that in an example coming up. Okay, so in example B, they show you 2 methods for adding a polynomial to another polynomial. The first is horizontally, just keeping them left to right and then combining like terms. However, I would not use those arrows because those arrows look like multiplication, like they almost look like distributive, and that's not what's happening. We're just combining like terms. So horizontally is fine, but I wouldn't use arrows. Vertically is a little extra step because you have to rewrite your problem, but it's kind of nice because you then end up lining up your like terms. So you got like terms there, you got all your like terms are all lined up, and it is all neat and set up for your answer. So I'll probably just do the horizontal method, but I like to use some color to help me identify my like terms. So I'm going to start with that. So in part A, I have a 4x squared, and I look over here, do I have any other x squareds? And I do, I have a 1x squared. So remember, you add their coefficients, you don't do anything with their powers. So 4x squared plus 1x squared is going to be 5x squared. Okay, I want to stay in descending order, so I think the next thing I want to look for is my x term, and I just have one of those. I have a minus 3x. And then finally, I actually have a constant, which is 3 plus 5, and that's going to give me 8. So I have 5x squared minus 3x plus 8. No tiles needed. Part B, let's go for the squares again. This time it's y squared. 10y squared plus 17y squared. That'll give me 27y squared. And then I can switch to my y's. I have 8y, oh, but no other y's to combine, so just 8y, positive 8y. And then I have the constants, which I do have 2 of. I have a 6 and a minus 11. So that's going to make negative 15. So no tiles needed. We're good. Okay. Oops, I meant negative 5. Sorry. Let's get that right. Negative 5. Okay. And let's do part C just for good measure. Let's start with the x term. So we have x squared. 9x squared and minus 13x squared. We're going to get negative 4x squared. And then I'll go to my x to the first, which is 15x to the first, plus a negative 11x to the first, and that is going to make a positive 4x. And finally, we have constants, 21 and a minus 26, and that will make a negative 5. And then we're all done with that one. Okay, so you can just look by combining like terms. Colors are helpful, okay, to keep your work organized. So that'll take us to the check your understanding, a couple of them with some algebra tiles and then some others, and then down towards the bottom, a little more practice with adding polynomials without the algebra tiles. So work on that, check your answers on the PDF that I have uploaded with the solutions, and ask questions in class tomorrow.